Hello and welcome to this IC6-1499 tutorial for the use of Function Block Development Kit FBDK coming from Holobloc.com. Today we are going to see the use of basic function blocks, building view and HMI layers of MVC pattern, which is model view controller pattern used to develop distributed automation systems. Once you visit holobloc.com website, you can find and download, well, in this case from the first link, FBDK. If I go there, you see, well, instructions, and in particular, you can download here FBDK 2.jar file. Once you download it, you can put it in some folder. Let's say you name this folder FBDK. I have it already here, FBDK folder and FBDK.jar. Well, I have also some other files, those those files and folder appear once you first time run this FBDK2 jar file downloaded from holobloc.com. So let me now start the tool. You can use this file to start the tool also on the first time or in the consequence times. I'm clicking FBDK2 jar, tool is initialized, and I need to click yes to accept terms and conditions and start the tool. And once I click it, a window appears for the Holobloc editor, which has, well, two main compartments, a tree structure, well, root element CRC showing libraries that you can use to develop your distributed applications. And on the right hand side, you would see the area where you can build actual applications and systems. So let's, as we speak today about use of model view control patterns, start using it. Let's see some of the most important folders. And in this case, HMI is one of the first we may need for building human-machine interface. And here you see, well, particular collection of blocks prefixed with in and prefixed with out. So it's for building your user interface, controls to input, let's say, some data, parameters to your application, and then read out what is going on in the application. In and out blocks. Another important folder, if we speak about model view control pattern and particular building view layer, is MVA folder. Here you can find one most relevant block to start with is match view. This is a template for building visualization of mechanisms, and block provides you different variations, parameterization, how this visualization of mechanisms should look like. With any blocks in any of these folders, libraries, you can double click on the block to check what a specification of a block. So let me try it with the match view. I double click and it appears in the tab in the main area here. You see block having some event inputs, outputs, and data inputs, outputs. In this case, match view block can be parameterized or controlled or used by providing a set of those data inputs starting with position. Once I click on the type unsigned integer for the position, you may notice that in the bottom of the tool appears a new area which is, well, having several tabs. If I first select XML tab and again click on the input, in this case there appears a comment mechanism displacement. So how this mechanism would be displaced. Then there are other inputs. You can go clicking vStyle, view style, foreground color, which is also workpiece color, can be interpreted, color for the background, unsigned integer for length in the diameters, and then diameter. This diameter is measured in pixels. So what is the basic unit in pixels for this mechanism? For instance, if this mechanism is handling disks, and you would like on your screen to have a disk drawn of diameter 20 pixels, so you just need to provide to this diameter input 20 value, and then if the entire mechanism transporting, let's say, this disk should be 100 pixels, so that the disk would be taking 1/5 part of the mechanism, then you should put here 5. So 5 times 20 gives us 100. So this how we play using match view block with the lengths or size of the mechanism. Then another important input for the match view block is VDIR, direction, view direction. And Holobloc and FBDK allow us to build visualization using 2D space, well, which is a screen of our computer, and directions could be right, down, left, and up in this context. So let's think about our first application that we would like to develop, and let's build a simplest conveyor loop. So let me illustrate what I mean. Let's suppose that we have 4 conveyor segments. In 2D space, this is the basic structure. Well, you can also see it here, allowing us to create a conveyor. So let me put it, well, one vertical bar. I am now copying pasting, so another conveyor for vertical arrangement, and then for horizontal arrangement, I'm just creating another bar and, well, aligning it in a certain way. Well, let's say like this, and then just again copying and pasting, so to form the loop. So I can highlight it in a different color. So here is our loop on the 2D space of 4 conveyors, so minimum loop we can have. But as you may already guess, once we need to form this conveyor loop, we even for this trivial task can have different, well, variations. We can put our conveyor loop here, well, this conveyor segment on top and this on the bottom, or even to have some more other more specific combinations, like having some of those conveyor belts inside. So you may imagine this for different conveyors, and there are actually many possibilities to build this conveyor loop. But let's focus on, well, given structure. And here would be important the flow in what we will be, well, the pallet or the product would be flowing on this conveyor. Let's say it would be clockwise. So we will have, well, flow on the conveyor 1, scene V1, to the right, here down, for conveyor 3, then left, and then up. So it's, as you may guess, the numbering in this example given just row by row, conveyor 1, conveyor 2, conveyor 3, conveyor 4. That's how reading goes here in terms of numbers. If we would like to have a counterclockwise direction, we will need to change VDIR, this match view block we saw a moment ago, parameter to have for conveyor 1 left, here down, for conveyor 4 right, and for conveyor 3 up. So if to make a loop flowing a different direction. So, but our match view block, and this vdir parameter already allow us to dictate those type of things. Okay, and once again, with any block, you can click and going input by input or output, check what is the meaning of each particular event or data. So like CNV is display updated in terms of view layer. Okay, but how and when and where we start to build our system in this Holobloc FBDK tool? There is another folder, important one to start with, which is template folder. And in this folder we have several, blocks to start with or entities to start with, which are system. There is also important basic and composite blocks, so templates for those. And in principle, there are possibility to build devices and resources. As you can see, the icons in the tree already show you or help you to tell what type of thing it is. So it's like networked boxes, network devices is the icon for system. Then device is a slot based box, composed block box, so it's device type icon. And then one single slot is a single resource where we can run different kinds of blocks. So therefore, let's start building our system. I'm going to again template folder and double click on a system. And once I double click, a tab appears in the tool containing, basic structure. So we would like to make a visualization starting as we talk about MVC pattern. We are making visualization on our screen of different elements, and especially we start with the view and HMIs at this moment. So we need to have corresponding devices there. I'm going to the system level and I delete from the system by going to this dev node, right mouse click from pop-up menu, I press delete to remove a device. So tree is updated here, so the system has no devices, and I go back to HMI folder to select a particular device called frame. So the frame is a window appearing on the screen of, in this case, computer, and I drag and drop our devices, and once I do this drag and drop, a window add device appears where I specify the name. Let me call, first device HMI device, and once I call this, you see that here an expansion appears in the tree and our device HMI located in the tree. But we need another device. Let me drag and drop it, another one to the working area of the system, and I call it, let's say, view. So just very simply, these would be the names. And again, view appears in the tree. You can reallocate those devices by dragging and dropping them in a tree, so changing the order here. But okay, obviously here is you change one is upper or down, so it doesn't affect the tree. So, but let's keep it in this order. Again, you see that structure of the device is a bit different than basic function blocks, and it's just used for parameterization. In this case of the frame device, it has bounds and grid. How to check what is the meaning of these bounds and grid? Same as we did with image view. Well, we can here, in this case, double click on the frame device type, and what happens, another tab should open where you can see, in the same way, what is the meaning of those different inputs, parameterization inputs for device. And as I select double integer 4, it's a array. It's a comma separated list of x, y, width, and height parameters for the frame device. Let's use it for a moment, and let's say that we would like that our HMI would be coming, well, here in the, as I'm showing with my mouse at the moment, in the upper left corner. We can remember that in the computer screens the coordinate system starts from the upper left corner, so 0, 0 coordinate, and x-axis goes from left to the right for this screen, and y-axis goes from top to the bottom, again from this upper left corner initial point for the coordinate system of all the computer screens. Okay, so let me make a right mouse click on the bounce, and for the popping up menu I'm selecting, well, default value, which is 0, 0. Please recall that first 0 is x and y, and then width and height. And once you double click on this value, another window for editing the parameters will appear. And for HMI I will keep 0, 0, and let's say I would like that this HMI would be 200 pixels width in terms of, well, size, and height for it would be 300 pixels. So for the third and fourth parameters, therefore I provide 200 and 300 respectively. Okay, parameters are set for the HMI. Now I would like that view would appear next to the right side, next to the HMI on my screen. How I do it? So, well, again, right mouse click, selecting default values, and then double click this default value to edit it. I would say that second parameter, which is a y, probably should stay the same, 0. Well, we would like to keep the level same, but x should be changing if we would like to have this view window frame appearing on the right hand side from HMI. So what should be the value? Very easy. I can check what it was the width of HMI, 200 pixels. So I put exactly same value, 200, so they really would be appearing next to each other here. So still, in order that this window would be visible and not collapsed, frame visible, I place some width and height, and let's for the HMI make it 300 and 300 as a width and height parameters. Okay, so in principle we are ready to test what we have created as our first system. But before, it's good to change the name. I'm going to the root here, clicking, and then double click on the system to edit the name. So let's check, let's name it CNV underscore loop as the name. Okay, CNV loop, for converse loop we're going for. Okay, and once I click, we see the name is changed. Now we can go to this small menu on the, well, left upper corner appearing here, which is save as, the first icon in the menu bar. So I click here, and what is important here is to highlight or check box to mark the checkbox for XML and press OK. So, well, tree somehow restructed, and you have the system appearing CNV loop saved and CRC. You must save each time your system as you edit it or make any changes to see the effect of those changes. But where you can find now this CNV file on your disk, so very easy. You go back to the installation folder of FBDK from where you have run FBDK tool, and you will find there CRC source code. folder. If I now open it, I can find what I can find. I can find cnv underscore loop sys, which was, well, just a minute ago saved to that crc folder. So that's a location of your project files as you work with them. Okay, good. Let's carry on. By adding some resources to our devices. As you remember the architecture for 6.14.99, we have system composed now of two devices, and the devices must have resources to run and host our application. And for this particular example, we should use view panel resource. Again, please check the icon as one slot to denote the resource. View panel resource to be used with our devices. Let's try, well, adding it for HMI and providing the name. Oh yeah, but before, I think I was also promising to start the device. As we save it, let's first start it, and for starting it we need to go and run. Right mouse click on the top and run. Let's first try to run it. Once we run it, we see two windows appears, and you can see these are coming in the upper left corner, and as we wanted, HMI is first, and then immediately after it on the right hand side comes the view. Those windows have a menu bar, cold, warm, events to be given to the device, and stop events to be given on the device level. And those are propagated to the corresponding devices. Well, this works fine. How we can stop it? We can again go to the root element of the system and press stop menu after right mouse click, and we get a message that process has been terminated. Good. Now let's carry on. For the frame devices, we go to the level of those and try to add resources, and I provide the name, let's say HMI underscore, well, resource, so nothing sophisticated, and we see our HMI resource with view panel, background, diameter size can be defined here. Actually, for HMI we could also use a rather panel resource for the frame device, but okay, let's carry on already with view panel for the HMI. And as I have added it and named it, you see that I can further extend this tree of a system and see it appearing, HMI resource appearing in the tree. And as I select it, we see this default block added on each resource, having cold, warm, stop, event inputs for our, well, resource. Well, there are outputs, of course, for this e-restart block, but we will use these events to initiate a different function block at the corresponding resources. Then let's add same, well, view panel resource at view layer, and let me call it let's say view resource. Again, nothing sophisticated, and here it also appears at the bottom. Now we have, as we look here, 300 pixels size for our view window. Let's try to have our view panel spread over the whole frame, over the whole window. How to do this? We can define a step. Let's let it be diameter at 20 pixels, and then a simple arithmetic operation should be used. How many 20s are needed to fill 300? so it is 15. 15 times 20, we get 300. And since it's a square, we see the size is by, well, width and height. So we specify 15 as the size. Again, each time we made some change and would like to test it, we can go, I'll save it as XML for given system, and then test it. Again, right mouse click on the root, and let's see what happens. We remember that we have added resources for view panel resources for both devices, HMI and view. Please check that at HMI there is now a small white rectangle having a default values for the panel. We didn't edit yet this diameter and size values for HMI view panel resource. However, we have edited and it's now white colored, taking whole well rectangle of 300 pixels, 300 pixels. So if I change the size, you see the coming gray area. So well, we just specify our panel to be just 300 pixels. Okay, I'm stopping again from the root element, the system. I can come back to HMI and also define there the size, and let's say that we can use the same step of diameter 200, and it was the width was in our case 200 pixels, so therefore I put here 10 as a first parameter and then 15 for the width. 15 times 20, 300, 10 times 20, 200 to specify the size. Again, well, I can immediately check if I'm on the right track by saving first and then running. And then in comparison to the previous results, you can see that there is no anymore an HMI small white rectangles, but the panel now takes the whole, well, screen of the HMI. Again, coming back to Holobloc and FBDK and stopping the system. Let's carry on with our cycle conveyor. Well, first thing I can say that we have 4 conveyors required for our problem, right? So let's add them, and it means that we need to come back to the MVA folder. Remember, we were discussing match view block there, and since we have 4 conveyors, I'm taking very basic, well, block, highlighting it. It's once again, sorry, just it tries to switch the view, but here I'm highlighting it, this block from MVA folder, and I drag and drop 4 times it to resource, view resource. First time, and I call it CNV for abbreviation for conveyor, CNV1. Okay, block appears. I drag and drop it again, CNV2, giving each time unique names, CNV2. Then comes CNV3, and finally CNV4. Okay, let's for the moment put them like this on the screen, arranging. And what we can see, we can see that in comparison to the previous view, when we had connections between events and data, associations with events with data, here when we develop some program already, there are no those connections, so which means we are making a composition of the blocks. And for the view layer, it's important the order in which we initialize the block. It's particularly important because it dictates in which order how the blocks will appear on the screen. Okay, so if I first initialize, let's say conveyor 3, so it will be coming first in the screen. If I initialize then conveyor 4, it will be coming after conveyor 3. So let's make it so that first comes conveyor 1, then conveyor 2, conveyor 3, conveyor 4, so like we have a calculation uh, uh, counting going. So I interconnect now cold when we power up our device and its corresponding resources. I am pressing down on my keyboard right now Alt key, and I'm drag and dropping event connection between cold and initial init input. Then I put, well, another init output of scene v1, pressing Alt key down and drag and drop my mouse to interconnect init output of the next init input of a next block. So in my case it works with Alt key. I also saw that in some configuration it worked with the Control key when you press Control key. So either Alt or Control must be pressed on the keyboard for interconnecting event and data inputs. So I create a chain now. So blocks would be initialized. If you forget to add this init input, well, basically you will not see any function or functionality appearing in your application if you forget to initialize the corresponding block. Now, let me go directly to directions and specify, as we were discussing, first conveyor to be pointing right, second pointing up, third pointing down, and fourth pointing left. How to do this? I go to this dir input, right mouse click, connect. Well, default value for vdir, then comes hash symbol to select this value from the enumeration type. There can be just 4 values: right, up, down, and left. Right, up, down, and left. Conveyor 2, again in this view, is up because it's finalizing the loop, therefore it's up, we can say, and therefore I select this value and I double click to edit it, and I put, instead of right, before the after hashtag, up. So that's how it works. Then I continue with conveyor 3 while selecting value, editing it, and I'm placing down after the hash tag. And as you can guess, for the last conveyor 4 in our list, I put left, all the capital letters. So the case for the letters is very important. If you misspell, it would be a mistake. Then now for the length. Let's say, we can know already that it's 300 pixels. Let's try to define something that can fit inside of 300 pixels that we put for our view layer for our visualization. So for example, we can put 200 pixels as a length of conveyor, and yes, these components, let's say, it still can fit, because if we put this 200, so the width would be about 200 of the mechanism. So let's say 20, 200, 200, 20, obviously 200 and 200. So it would be therefore whole height 240, so 20, 220, 240, and width of the whole structure, let's say, would be just 200, because these segments, we would like to put them embedded in this case. Okay, let's see how we can do it and what we need to take into account. Well, as I already was telling, let's put diameter like a basic unit for measuring our mechanism. It's visualization 20 pixels for all mechanism. Of course, you can play with this if you would like to have a different uh, well, height, widths of different mechanisms joining together, but these are the parameters to start with. And then, since lengths of all the conveyors are the same, and we set for the convenience 200, for the length I put 10. Once again, same as we have been defining the boundaries or well the size of the resources view panel. We use it as a multiplicator multiplier for diameter. So 10 times 20, 200 pixels as a whole length of mechanism. So same I do now, all the same for all the values. Okay. Yes. And let me save it for a moment and let's immediately test what we will see when we try to run this system. Okay, it's saved. I go to the root, right mouse click, run, and we get something, well, of this strange, well, somewhat strange shape. I may say that this is conveyor 1, this is conveyor 2, I mean, it's just joined the boundaries, this is conveyor 3 of blue color, and then here hanging conveyor 4, just in the middle. You see it's kind of divides the area we have for the view into middle, by the middle. So well, the idea is as we look to this interface and we'll remember the resource, we have a vertical input here. It means well, by default I can show by default it's fills row first. We place different components, I think, until we have a space. So we place first, we place second, we have third one, and then we need to put fourth one. But okay, this space is already occupied, and therefore this segment goes here. In principle, it's possible to put column first, and then these segments start to appear, this conveyor segment starts to appear, well, after, below. And this is first place and spot where you can start to control, like where and how you would like to arrange it. But what I will do instead, I will use additional important block from MVA folder, MVA library, which is, for our case, XSPACE. XSPACE, let me find it, yes, here in MVA folder, XSPACE. And I will be now using it for arranging properly the view. Let me drag and drop XSPACE here to the view, and let me think how we can call it. Well, just space 1. Let me, well, once again look how it used to appear, the view layer, and I am now stopping the system. Okay, and let's see how after the changes thing would come. Now, our first conveyor occupies 200 pixels, 10 times 20 pixels. Obviously, for the 300 pixels width, what we have for the whole frame panel there, we have still free room, extra room, and this extra room is, well, remaining 100 pixels. And how this extra room is occupied? Well, very easily. We see that we have vertical conveyors because we used up and up here and, well, and down here, so vertical in any case. alignment. Therefore, the diameter was 200 pixels. So it was 200 taken by conveyor 1, then 20 and 20, 240 in total. So from 300 there are 60 pixels left. It was not enough, those 60 pixels, to fix and put this conveyor 4. Therefore it was appearing after like a new, well, row, let's say. So in order to put conveyor 2 to the next row, one of the approaches, I can use this XSPACE block, and this XSPACE block would be used to take this remaining 100 pixels after conveyor 1. So what it means, I will use the same diameter, 20 pixels, and then I say, aha, this block occupied conveyor 1 200 pixels. From 300 we have for the panel, we have remaining 100 pixels, which is, if we speak about width, 100. So 5 times 20 will give us remaining 100. And let's put here 15 as a second parameter. So we insert XSPACE, which would be occupying whole this 100 pixel stripe on the right hand side. So in order to put our conveyor structure really to the left hand side of the UI, user interface of view frame. Okay, and the stripe would be coming on the right hand side for the whole height of it. So that's why I have here 15, and now I need to change the structure of initialization. You remember that depending on initialization order things are appearing. I am making right mouse click to disconnect conveyor 1 from conveyor 2, delete. Okay, and I'm inserting in between this XSPACE block. Pressing Alt key down on the keyboard, drag and drop by the mouse, I interconnect init outputs and init inputs, and immediately, just with this small change, let's go and save our system. Right mouse click to run it, to check how it would appear. Okay, we see conveyors gone. Okay, now I need to take a moment to think why it happened. Let me stop it. I come back to the view resource. Conveyor 2 was initialized. Let me double check XSPACE specification in terms of dimension. Yes, we forgot to specify for the dimension is 2 parameter 2. It's also array for the no, sorry, I'm jumping. No, it was correct, but dimensions first comes width and then height. First comes width. Oh, okay. We had 100 width, and then height 300. So looks okay for me. I have initialized both conveyors. Let me try to check again. Let me just make a small 5 rectangle. Debugging and hunting for missing block. Okay, saved. Yes, I save it all. Run again. Okay, now it appeared. So here looks, yes, we have correctly calculated the width, the height. Okay, because this is looks like 100 pixel rectangle. Let me come back and understand what mistake I'm making. Again, jumping to XSPACE, looking, first comes width and then comes height. Should be 15. Still, I don't yet see what is happening here. Yeah. No, sorry. Yeah, I got it. The reason is that it's still tries to put after start the next row, as we saw in visualization, and yes, it should be rather 1 to allow it to start the next row. Yes, I'm a bit confused myself and you. So it should be 1. So let me just explain it again when I started the system before saving it. So now it appears correctly. So we have taken this area, and I was trying to put before 300 pixels, but next row, which means all these conveyors continuing coming afterwards. So that was, well, a mistake, and therefore it was not visible in view screen. So it should be 1 in 20 pixels multiplied with 20 pixels. Okay, you see, it's quite challenging even for me to use this block, but we can now carry on locating conveyor 2, which is now here, conveyor 3 is here, and conveyor 4 here. Again, please look, this is considered as a single row somewhat, and since 200 pixels, 20, 20, 240 is enough to fit in the area of 300 pixels, so they are coming now in this configuration. So therefore, to carry on, I would need another XSPACE blocks. I can use different ways. I can just make right mouse clicks and copy and paste, but I need to change obviously the name, as this should be unique. I call it space 2 block, and then I need to edit parameters. So after conveyor 2 appears, on the left hand side, we need to take this area. What should be the width of this area? Well, these 20 pixels are taken. These 20 pixels are taken from 200, what we have the length of conveyor, so which leaves us 160 pixels, right? Or if we divide 160 by 20, 8 times we take, well, this width. So 8 times. And what is the height? Actually, we can calculate, because we fit whole conveyor, we can say it's 10. But 1 would be also enough, because it's row by row filling. And we have already this vertical conveyor 2 and conveyor 3. We do not need to put here, well, exact number. 1 would be enough, but in principle it is 10, which is taking the whole length of those conveyors, conveyor 2 and conveyor 3. Okay. So let me put just explicitly 10, although again it can be just 1. And what I do, I again make right mouse click, delete, yes, and insert this space block in between initializing initializing those blocks, making another save. And let's see again immediately what would be our result. I have to stop, well, previously running system, right mouse click, and then I start again with right mouse click, another system, and what we have? We have, well, I may say conveyor 1, conveyor 2, conveyor 3, and again conveyor 4 hanging in the other row, and it's in the middle dividing UI, so we need still another XSPACE block added. So I do stop currently running system and I add another space block, making right mouse click copy, right mouse click paste, and naming as a space free block. And where should I put it? Well, actually we could have copied space 1 rather, because it has right values of coming after conveyor 1. Well, we have symmetrical picture for the low row. It should be, well, appearing here, well, if I show it on this structure. Therefore it comes at the end, our space 3, and I use for the size dimensions 5 and 1 as input parameters, and I initialize it, this final block, save it, save it, save it, and I run it. Perfect. We have a perfect loop of our conveyors. Just a note, you can have on the view layer also some inputs which are coming to the level of application, and this is fault outputs. You can validate your application by providing through the view layer fault inputs, just as a side note for you. But using XSPACE, we were able to create, well, nicely looking well, basic square. Then just another little bit of cosmetics. Let's see, in XSPACE block we use another input, which is LBL's labels, and it's a comma separated list containing left, top, right, bottom, and center. So 5 parameters: left, top, right, center. Let's make our conveyor loop, our visualization layer look a bit more descriptive than it's at the moment. And how we would be doing it? Let's add explicit labels. On the left it would be scene v2, on top it would be scene v1, on the right scene v3, and at the bottom scene v4. How to do this? Well, we need to come back to our system and remember that here we have our space 2 block, in the middle 8 times 10th dimension, and by the way here this 10 becomes important if we want labels appear nicely to the corresponding, next to the corresponding conveyor. So I add right mouse click labels and a comma separated list, left, top, right, bottom, and center. I put scene v1, comma, sorry, it was should be starting since on the left scene v2, then scene v1, then scene v3, and then scene v4. So only 4 values needed. Again, as always, checkbox for XML, save icon first before we try to run it. And okay, stop previous one, which didn't have any labels. and running a new system. Let's see. We have scene v1, scene v2, scene v3, conveyor 4 appearing exactly like we have been wanting those conveyors to be located. Well, maybe this we can reconsider that from the user perspective, and if we use clockwise rotation of the pallets in this structure, it might be needed to rather use the numbering 1, 2, 3, 4, but at least we have been able now to put it based on our initial thoughts. Okay, what we have seen so far is a system, is the use of basic match view component function block, use of XSPACE to arrange our basic view layer interface. Next, we continue with the HMI and interconnection of the HMI level with the view resource.